morning, this is Amy Johnson, and it's Pi Day, and I actually really like this project that I just found. I opened it this morning because I had to quickly change lesson plans for one of my classes today because, yeah, you don't even need to know why. And this is something I had written 4 years ago, and with a couple quick little tweaks, I realized, my goodness, this completely fits our problem solving video challenge. Now I realize I'm one day late, but I got very excited when I saw this, and I don't feel as guilty using this as I do using the sheep problem. So I don't even know if this can be considered, but this is going to be my video. The reason I'm choosing this is because, number one, my students beg to celebrate Pi Day every year, and I don't do a whole lot that's exciting and or fun for them. But I also use it as a chance to really work on those problem solving skills. I forgot that I had done that in the past. Last year I was so frustrated I canceled Pi Day altogether and we didn't even celebrate it. But this year we are, and so I resurrected this document, and the nice thing is that I can tweak it to work with all of my classes, and the purpose of it is, number one, to build those problem solving skills. That is why I would choose it. And number two, it reinforces things. We're getting close to testing season, and so for any junior I have, this is pulling back all sorts of different. I know we're supposed to have one specific skill in this lesson video, but there is not one specific skill in this video or in this worksheet that I've created. It kind of applies to, as you can see up here on the top, intermediate algebra. They don't have as many questions that they can complete using formulas, but problem solving skills, there's quite a few of them that they could go through and give an attempt to. Algebra 2, pre-calculus, and calculus, and this year I'm actually tweaking it for statistics as well, but this is the old one I did with a little bit more in. I have a bundt cake pan, so it is parabolic in shape on the outside, and it has an inner radius and an outer radius. And one of the goals that I want to work on in this is measuring skills. My kids apparently do not know how to measure well, and so getting accuracy and figuring out how to do that alone, I'm always shocked at how hard it is for them to figure out how to measure. So that is one, and they have wonderful discussions to try to get through that. So I make all these little blanks that you're going to see on this worksheet. I have them actually measure, come up with a plan on how to measure. My classes are very, very small. My largest class this year is actually only 18. I did have 30 a couple years ago, and when I've got the big ones like that, I break my kids into smaller groups, and on Pi Day, it's a fun day, so I let them choose their own groups so they can work together. And I realized it exactly matches what we want. Most of my classes, my upper level classes, honestly, are 4 people, and so they are a built-in group. We're kind of a team as we go along. One of my students calls it a powwow. We just kind of work together and do what we need to do, and I facilitate. So this fits perfectly into something like that. So I would have them measure, and then this first question, I want them, all of my classes, intermediate algebra through calculus, have worked with parabolas by now. And they've all worked with vertex forma parabolas as well. And so they've also generated equations for parabolas. I just have never made them measure something in real life and think through how to do it. So the question that is posed on this first one is, can you find the equation of a parabola that will represent the shape of this cake pan? And I should put the word pan in there, but cake will work as well, so I'm not going to switch that. And then a lot of them wonder, well, why would you ever need to do that? And so I actually threw in, this is an equation machines would use to form a mold for the pan. I'm being general there. And if it were programmed in, they could simply change numbers or sliders to make a different size pan. I'm hoping with my use of the word sliders that the kids will think Desmos and they can kind of play with things to see if they can generate something. Then I threw in a lot of the Polya problem solving skills that we were working with, and some of Schoenfeld's stuff too. I kind of just put it all in there. I wanted to give them a hint, and I would tell all of my students at the beginning, go back and look at the hints for question 1, because with the exception of the parabola specifics, you can use these on every single problem that we've got. So one is, what are you being asked to find? what do you already know? What do you need to know? Devise a plan, and I am hoping, among all hopes, that they draw a picture and create a graph. When I did this 4 years ago, they did. And my upper level classes came up with the equations. My lower level classes chose to skip this question and move on to other ones. I did make it something where they could choose the problems they most wanted to work on. And this is more high level. I have a lot of questions on this worksheet, as you can see, and I just wanted them working. I didn't want it to be a wasted day, and I wanted them to work on problem solving skills. So that's what we were going with this. Try a simpler problem first and then see if you can adapt it to this one. What would be the easiest place to make the center of your parabola? The vertex, another point or two on the parabola. I'm just trying to give them hints on what they could go with to do that. Then the next question was, oops, sorry, I went there. Only for calculus. We have just finished learning how to find the area under a curve. And so I'm hoping if they could generate the equation, they could figure out how to find the area under a curve. And I'm going to leave those hints. And of course, with me being in the room and only 4 of them, the challenge is how long do I let them struggle before I jump in? And it's when I start to see the mad pencils get pushed down and they quit conversing altogether and they just start staring, that's when I jump in and start prodding more. But I try to encourage the conversation. So we've got the area under the curve. Then we're moving into volume shortly with calculus, and this would be a nice question to adapt to that as well. But none of them know how to do it with a formula yet. And I thought, you know, we have been presented with several things in our problem solving class where we don't necessarily know a formula. We just have to do a lot of guess check challenges. And so I thought, this used to be for geometry as well. So I used to have geometry in my thing, and this was a question I really encouraged them to attempt. Can you find the volume for the pan? You don't have to be exact, so I'm not saying you got to find a formula for it, but can we figure out something that would give us a close approximation? And let them kind of work their way through those things. Hints, again, going back up to the beginning. My 4th question is, the kids are bringing in pies, so we can celebrate with real pies. I'm going to have them measure the radius of the pie, and they'll discover that they don't know how to get the radius, so they usually ask, can we just do diameter? And then we go from there. But as long as we get the measurements, then we go from this. We have to measure before we can eat. So the kids are usually pretty good at breaking up the measurement tasks, and they go with that because they want to eat. And then I was thinking, because pies have a slope or a slant on the edge, most of them. And so then I love, for my lower level kids, the idea of seeing, all right, you've got 2 circles there, figure out a slope or a slant, see if you can go with this. However, my intermediate algebra kids at this point don't know how to write the equation of circles, so I'm not convinced that they would go with that. As a matter of fact, I don't know that any student worked on this problem when I did this 4 years ago, so we're going with that. They did all do the Oreo one, and Oreo has a circumference, measured the circumference around it. Then I wanted them to go in and get the diameter, area of the top of the cookie, height of the Oreo, and then go to volume, surface area. That was very geometry specific at that point. But I figure all of my kids have learned it at one point, so they can go back and kind of work on it. Donuts, inner ring, outer ring, maximum height, and then here I went with cross sections. I wanted them to see if they could come up with some cross-section things. And again, drawing a picture and letting them know you could choose more than one type of cross-section in order to work with on that. And then I also order pizza for the kids. And so pizza coming in, measure the diameter. However, all of my kids are from a small town. Most of them know the diameter of the pizzas supposedly from there. So they might not have to measure. They could just put this in and go with it from there. They might ask, can we switch it to inches instead of centimeters? And I would be okay with that. And then goes from there to how many slices it in, what's the area of the whole pizza. I thought I had, what is the area of, area of one piece of pizza, assuming each piece is congruent. What is the circumference of the pizza? What is the measurement of the central angle for each piece? It's more open-ended than I usually do, and it is more of a problem-solving type of activity, and this is mine, not Dr. J's, but a day late. Happy Pi Day!